Here we've got a pulley that is a hoop on the left and a pulley that is a disc on the right. Which block is going to reach the floor first? Both masses are equal, both masses of the pulleys are equal, both radii of the pulleys are equal. So who's going to win, the block on the left or the block on the right? To figure that out, we need to figure out which pulley is going to be harder to rotate. Well, we already know the disk has more atoms closest to its axis of rotation, right in the middle. So that must mean the moment of inertia for the disk is going to be tiny, because the distance from the distance the atoms are from the axis is tiny. Here, the distance is pretty big. It's pretty close to the full radius. So that means the moment of inertia over here is going to be a lot bigger. If your moment of inertia is bigger, then it's harder to get this thing to rotate. If it's harder to get it to rotate, two equally massed objects accelerating in the same field of gravity are going to rotate at different speeds. This one is going to be harder to rotate, so it's going to take longer to start rotating. Of course, if we wanted to figure out which disk or pulley or disk or hoop would be harder to slow down, it would also be the hoop. So it's going to be harder to get this hoop to start spinning. It takes more effort, more torque to get this thing to start going. Whereas over here, it only takes a tiny little bit of torque to get this to start rotating. Which rope is going to have greater tension? I think I answered that one already when I said that this one is going to take more torque to pull it down. It's kind of a spoiler for the next unit, but torque equals I times alpha, in the same way that F equals ma. Linear version, rotational version, linear version, rotational version, linear version, rotational version. So torque equals I alpha. This one's going to have the smaller angular acceleration because remember it's going to be harder to get this thing to start going. So that means the force being applied, torque also equals F times R. Right? So F times R equals I alpha. So wherever you have a greater torque, you're going to have a greater force. And that greater force is going to lead to a slower angular acceleration because our rotational inertia is small. So the one on the left, because of that reasoning.